So we're starting chapter 4, section 1. We're going to be doing systems of linear equations. Page 209 talks about the Bill Cosby show. Chet Kincaid, a physical education teacher, in the episode Let X Equal a Lousy Weekend, Chet must substitute for an algebra test. He and the entire class are stumped by the following problem. How many pounds of candy that sells for 75 cents per pound must be mixed with candy that sells for $1.25 per pound to obtain 9 pounds of a mixture that would sell for 96 cents a pound? The smartest student in the class eventually helps Chet solve the problem. You're going to do stuff like that in this learning plan. We are on learning plan 2.6, and we're going to be solving a system. Oops, I'm sorry. I got to get the pen first. A system, that means two linear equations, so they're going to be lines. And when you have two equations, you would have two variables. So we're going to tell whether something is a solution. We're going to solve by graphing. We're going to solve by substitution and elimination. And then there are some special systems that we're going to be solving too. So let's look at page 210, and we can see we've got a system of two. Notice they are linear equations. There are two variables, years and dollars. Okay. And there is a solution, and that's right here where the two lines cross. So that would be about year 2001 or so, and it would be about $3 million in sales, something like that. Okay, so how do you decide whether something is a solution? A solution solves both equations at the same time. So let's check to see, if I substitute 4 in for x, 2 times negative 4, plus 2, do I get negative 6? Well, this is negative 8 plus 2 is negative 6 is yes. How about for the second one? Negative 4 plus 3 times 2 is 6. Negative 4 plus 6 is 2. If both answers are yes, then this is a solution. You do this one. Okay, so for the first equation, negative 2 plus 2 times 5, do you get 8? Yes. That's 10 minus 2 is 8. How about for the second one? 3 times 2 minus 2 times 5, do you get 0? No. So this is not a solution to the system of equations. How about this one? 3 plus 5 is 8, so it does work for the first one. 3 minus 5 is negative 2, so it does work for the second one, so it is a solution. So that's pretty much how you do those. Now, we can also solve systems by graphing. Let's graph these two equations. This first one, probably the easiest way to graph it would be to write it as intercept slope form. I just saw that the y was all alone, so I'm going to write y equals negative 2x minus 5. I moved the 2x to the other side. So my intercept is negative 5. From there, go down to forward 1. I'm going to go up to back 1. And so my graph is going to be like this. All right, and then the second one, I'm going to solve using intercepts. So if x is 0, y is 2, and if y is 0, x is negative 6. So those two are going to be something like that. I'm going to say the solution is right here. Now the problem is, because I didn't graph it using a straight edge, I'm going to guess that the solution is negative 3, 1. Now if you check that, negative 3, 1 does work for both equations, so it is the solution. Okay, you do this one. I'm going to solve both of them by intercepts. 3x, if x is 0, y is negative 3. If y is 0, ach du lieber, did I do that wrong on this one? If y is 0, x is negative, yeah, you got that one right. Let's do this one over again. If x is 0, y is negative 3. If y is 0, x is positive 2. That's the first line. If x is 0, y is negative 1. If y is 0, x is positive 1. That line's going to go like that. And so the solution is out here, which I'm guessing is the point 34. I'm just guessing that because notice this line I kind of had bending down a little bit. No, it's not 3, 4. 3, 2 maybe, huh? Try 3, 2. 3 minus 2 is 1. 3 times 3 is 9. Minus 2 times 2 is 4, is 5. So it's not, it's probably going to be a fraction of some kind. I don't know what the coordinates are, but it's someplace over here. 3, 2, 3, 2.5, somewhere in there. Okay, this would be an example of one that, the first one I would solve by intercepts. Y equals negative 4x plus 10. So my intercept is 10. From there go down 4, back 1. So it's going to go something like this. And for the second one, I would get 3y is negative x minus 14. Divide everything by 3. Negative 14 thirds is down here. From there, go up 1, back 3, be about like this. So my solution is right there. Now, the different disadvantage of solving by graphing is you don't know exactly what the point is if you didn't graph using a ruler, or if your graph was just a little bit off. So you want to be careful about that. But if you have one point where they cross, we say the system is consistent and the equations are independent. If you have parallel lines, it is inconsistent. Remember how you say, oh, Mom, you're so inconsistent? Well, that's because what you say doesn't match what you do, so they don't cross. These two would also be independent. If you have one line, then you would say the system is consistent, meaning they do cross, and in fact they are the exact same line, so that we would say they are dependent. So when you go to solving a system, there's probably a better way than to solve by graphing. The first way we're going to learn is by substitution. As I said, it's difficult to read the exact coordinates of an equation from a graph, so we usually solve using, in this case, the substitution method. If one variable can easily be substituted for the other variable, then you'd use the substitution method. In this case, notice x is already all alone, so whatever x is in the second equation, we would write into the first equation. So instead of writing x, I'm going to write 2 minus y into the first equation. Minus 3y equals negative 6. And then I'm going to multiply it out. I get 10 minus 5y minus 3y equals negative 6. 10 minus 8y equals negative 6. Add or subtract 10 from both sides. I get negative 8y is negative 16, so y is positive 2. Then I substituted that back into the first equation. The second equation. Y is 2. 2 minus 2, x will be 0. Y is 2. Next one. You try this one. Notice the x is already solved, so instead of writing x in the second equation, we're going to write 3 plus 2y. Minus 3y equals 32. So this is 12 plus 8y minus 3y is 32. This is 5y. Subtract 12 from both sides. You get 20. So divide both sides by 5. You get y is 4. Substitute that back into this first equation. 2 times 4 is 8 plus 3. So x will be 11 when y is 4. Try this one. Notice we've got another easy substitution. Negative 2 times negative 9 plus 2y minus 3y equals 4. So instead of writing x into the second equation, I wrote negative 9 plus 2y. So this is 18 minus 4y minus 3y equals 4. 18 minus 7y, so I'm going to subtract 18 from both sides, and I get negative 7y is negative 14, so y is 2. Okay? If y is 2, substitute that into this first equation here. Negative 9 minus... Did I make a mistake here? Nine plus 2y, negative 4, positive 18, negative 7 plus negative 14, positive 2. 2 times 2 is 4. Negative 9 plus 4 is 5. Negative 5, so my answer is negative 5, comma 2. Next one. So if you're solving by substitution, it's easiest if one of the coefficients is 1 or negative 1. Substitute that into the other one, solve that equation, substitute back into the first equation, and then check your answer. Sometimes we have a system like this where you can't obviously see that y can be made all alone by rewriting that first equation as y equals negative 4x plus 5. So I move the 4x to the other side. Now I can substitute this into the second equation. Minus 3y equals 13, and multiply it out. 8x plus 10 minus, I'm sorry, that's not 8x, 8y plus 10 minus 3y is 13. Gotta make sure I got that right. Y is, oh, I didn't get that right. Y is negative 4x plus 5. So 2x minus 3 times negative 4x plus 5 equals 13. You gotta watch out there. I tricked myself because I have to substitute what y is. So 2x plus 12x minus 15 equals 13. This is 14x. Add 15 to both sides. Equals 28. So x equals 2. Substitute that into this equation. 4 times 2 is plus y is 5. 8 plus y is 5. Y is negative 3. So my solution is 2, comma, negative 3. You do this one. Okay, it's easy to see that y can be made all alone. So we get y equals negative 5x plus 7. And now we're going to substitute that into the second equation. 3x minus 2, parentheses, negative 5x plus 7 equals 25. 3x plus 10x minus 14 equals 25. Add 14 to both sides. 3x and 10x is 13x equals 39, so x is 3. If x is 3, negative 5 times 3 is negative 15 plus 7 is negative 8. So our answer is 3, negative 8. Try this one. Okay, rewrite the second equation as y equals negative 2x plus 30. Substitute that into the first equation. 5x plus 3 parentheses negative 2x plus 30 equals 80. 2 times 3, so it's 5x minus 6x plus 90 equals 80. Subtract 90 from both sides. And combine these two, you get negative x equals negative 10. So x is 10. Substitute that back in here. Y equals negative 2 times 10 plus 30. Negative 20 plus 30 is 10. So x is 10 and y is 10. Okay, so that's solving by substitution. Now, if you have a fractional exponent one like this, I would always clear the fraction by multiplying by the least common denominator, 4. And I would get half of 4 is 2x. Half of 1/4 is 1y. Half of 4 is 2. Now you can see that you can substitute y equals negative 2x plus 2. I move the 2 to the other side. So into my first equation, instead of writing y, I'm going to write negative 2x plus 2. So it's negative 2x plus 5 parentheses negative 2x plus 2 equals 22. Negative 2x minus 10x plus 10 equals 22. Negative 12x, I gotta make sure I got this right. Negative 12x, subtract 10 from each side, equals 12. So x is negative 1. Substitute that in here. Negative 2 times negative 1 plus 2. This is 2 plus 2. So x is, negative 1. Y is 2 plus 2, which is 4. Okay, let's try this one. Common denominator is 10, so multiply the first equation by 10. A tenth of 10 is 1. 3/5 of 10 is 6. And 2/5 of 10 is 4. The other way you could do it is simplify. This divided by this is 2. This divided by this is 2. 2 times 3 is 6. 2 times 2 is 4. So that's the other way you can do it. 2 times 2 is 4. Okay, now let's rewrite this as x equals 6y plus 4 and substitute. Negative 2 parentheses. 6y plus 4 plus 3y equals 1. Negative 12y minus 8 plus 3y equals 1. This is negative 9y. Add 8 to both sides. We get negative 9y is positive 9. So y is negative 1. So we have 6 times negative 1 plus 4 is negative 6 plus 4 is negative 2. So x is negative 2, y is negative 1. If you have, both equations with fractional coefficients. So I would multiply the top equation by 20 and the bottom equation by 20. And I get 1/5 of 20 is 4, 1/4 of 20 is 5, 3 times 20 is 60. 1/5 of 20 is, 2/5 of 20 is 8, 1/2 of 20 is 10, and 3 times 20 is 60. Now, in this case, I would solve by elimination rather than substitution, just because I don't like working with fractions. If I multiply the top equation by -2 and write it down here, I get negative 8x plus 10y equals negative 120. Now when I add them, these cancel. I get 20y equals negative 60. So y is negative 3. I'm going to substitute into the first equation 4x minus 5 times negative 3 equals 60. 4x plus 15, 60. Subtract 15 from both sides. I get 4x is 45. X is 45 over 4. Y is negative 3. So sometimes you get fractional answers when you have a fractional equation. Okay. Elimination. As I said, elimination is easy when they have coefficients that are the same with opposite signs. We also call this solving by addition, and you'll see why. We're going to add these two equations together. Negative x and 2x. 3y and 2y is 5y. Negative 10 plus 5 is negative 5. Divide both sides by 5, I get y is negative 1. So I can now either substitute or I can go back and eliminate the other variable. I'm going to substitute the second equation. 2x plus 2 times is 5. 2 is 2x is 7. X is 7 halves. So my answer is 7 halves and negative 1. Okay, so you do this one. As you can see, an easy one to eliminate the y's. Add them together, we get 13x is negative 13, so x is 1. Now I'm going to substitute that into this first equation. 8 times 1 minus 2y equals 5. Subtract 8 from both sides. I get negative 2y is negative 3. Divide both sides by negative 2. I get, when x is 1, y is 3 halves. Next one. As you can see, it's an easy one to eliminate the y's because the 7's are the same. We can solve by addition. The y's cancel. We get 4x is 14, is that? Let me think. 16. So x is 4. Substitute that into the first equation here. Negative 4 plus 7y equals 39. Subtract or add 4 to both sides. I get 43. I did something wrong here. 4x negative 39 plus 15 is negative 16. I'm sorry, so the x is negative 4. So this is positive 4, subtract 4, I get 35. 7y is 35, so y is 5. Yeah, I saw that I was going to get a fraction, so my answer is negative 4, comma, 5. Okay. Next one. So when we eliminate, we match them up so that the coefficients match, which sometimes means you may have to multiply and then substitute to find the other value. Now in this case, I'm going to solve by multiplying the top equation by 3 and the bottom equation by 2. And when I do, I get 6x plus 9y equals 57. Bottom equation by negative 2, I get negative 6x plus 14y equals positive 12. Now when I add them, the x's are eliminated, and I get 23y equals 69. So y is 3. I'm going to now multiply, I'm going to change colors so that you can see what I'm doing here. I'm going to multiply both equations by the top equation by negative 7 and the bottom equation by positive 3. So I'm going to, basically what I did is I switched these two coefficients and I switched these two coefficients. So I get negative 7 times 2 is negative 14. X, negative 7 times 3 is minus 21y, equals negative 7 times 19 is 133. I'm going to make sure that's right. 140 minus 7, yeah, negative 133. Bottom equation by positive 3, I get 9x minus, oh, these should all be pluses, sorry, plus, minus 21y equals negative 18. So I get 23x equals 18 away from 133 is 125. 23 goes into 125 not evenly. Must have done something wrong. Should be 5. 23 times 5, is that? No, it's 115. This is supposed to be 115. That's what you don't get when you don't have a calculator. Divide both sides by 23, and you get x is 5. So my answer is 5, 3. Now the other way you can do it is once you solve by elimination, you can just substitute in to find the other answer. So you try this one. Okay, I'm going to multiply the top equation by 2 and the bottom equation by 5, and by doing so, I'll eliminate the y's. So I get 4x minus 10y equals 8, and 25x plus 10y equals 50. Add them together, I get 29x equals 58. So x is 2. I'm going to substitute that into that first equation. 2 times 2 minus 5y equals 4. 2 times 2 is 4. 4 minus 5y is 4. I'm going to subtract 4 from both sides. I get negative 5y is 0, so y is 0. So my solution is 2, 0. There are special cases. Let's look at this first one. if we would substitute the first equation into the second equation, y equals negative 2x plus 6, so I move the 2x to the other side, I get negative 8x minus 4 parentheses negative 2x plus 6 equals negative 24. Negative 8x plus 8x minus 24 equals negative 24. Combine these two, they are 0. Negative 24 equals negative 24. Well, of course it's true. When you get a statement like this, you've got the same equation written two different ways, which makes it consistent, and they are the same equation, so they are dependent. And so we would say there are a number of solutions. Next one. If you try adding these two equations together, so let's multiply the top equation by negative 2, and write it down here, we get negative 8x plus 6y equals negative 16. These cancel, and so we get 0 equals negative 2, which is false. And so these two lines are parallel, and we would say they are inconsistent and independent. All right. You try this one. Okay, let's solve it by multiplying the top equation by 3, and writing it down here. We get negative 6x minus or plus 15y equals 18. Adding it to that one, these cancel, and we get 0 equals 22, which is false. And so we've got parallel lines, inconsistent, no solution. All right. So if both variables are eliminated and the statement is true, there are infinitely many solutions. If the statement is false, there is no solution. Now, you can use the slope-intercept and tell how many solutions there are. So let's solve this first equation for y. We get negative 6y equals negative 3x plus 9. Divide both sides by negative 6. And we get y equals 1/2 x negative 6 minus 3/2. Second equation solved for y. We get negative 2y equals negative x plus 3. Divide both sides by negative 2. And we get y equals 1/2 x minus 3/2. Notice these two equations are the exact same, and we would say there are an infinite number of solutions. Now, if you notice, you can also use our fact that the slope here is positive 1/2, 3/6 is 1/2. Slope here is positive 1/2. Remember, you take the coefficients and change the sign. The slope is the same, the intercept must be different because those two numbers are different. Remember, the other way that you can tell the intercept is you put this number on top, this number on the bottom. Now it says to write them in the intercept slope form to tell how many solutions they have, but let's do it the other way just so that you see that it's true. 2/3 is the slope. 4/6 is the slope, which is 2/3. So they have the same slope, and if you notice, they do have different intercepts, and so there is no solution. Here, divide both sides by 5. Here, divide both sides by 10, negative 10, the first equation becomes y equals negative x over 5 minus 4/5. Second equation becomes y equals negative x over 5 minus 4/5. They are the same equation, so you have infinite number of solutions. Tell how many solutions it has. Don't solve. Okay, so we write the slope 5 over 5 negative is negative 1. Second equation, 10 over 10, change the sign, is negative 1. So in both cases, the slope is the same, but the intercept, you'll notice, is, in the first case, is negative 4/5, and then the second case is negative 8/10, which are the same line, so there are infinitely many solutions.